We're going to look at some examples of mixture problems. In this example, we already have the table set up so we can make sense of where everything is coming from. It says find the concentration of the resulting solution when 800 milliliters of a 12% acid solution is mixed with 200 milliliters of a 8% acid solution. So we typically use tables to organize what's going on. In the first row, under solution type, we typically just name them solution 1, 2, or 3. If you'd like to name them based on information in the problem, you can. We also need the amount of solution in milliliters, the percent strength, and then combined, which we'll always get from doing multiplication with those first two columns. So if we read through the problem, they tell us that we have an 800 milliliter solution. That's where this 800 milliliter come from, of a 12%. So that's our 12% solution. Then they tell us that it's mixed with 200 milliliters, so here's our 200 milliliters, of an 8% acid solution. Then they're asking us to find the concentration of the resulting solution. So if we look at that resulting solution, it's from mixing these two solutions together. So this 1,000 milliliters is coming from doing our 800 milliliters plus the 200 milliliters. We don't know that percent strength. They're telling us to find the concentration. So that's where we get our X. And then this equation down the bottom is gotten from mixing the two combined together. So the 800 times 12 plus the 200 times 8 equals our 1,000 times X. Let's look at an example from scratch. If we look at this, it says how many milliliters of a 12% acid solution should be mixed with 500 milliliters of a 20% solution to obtain a 17% solution. I'm going to start by setting up my table. They're telling me about 3 solutions again, so I'm going to have solution 1, solution 2, and solution 3. For each solution, I'm going to have a milliliter and a percent, and I'm going to use them and multiply them to fill in this third column. So if I read through the problem, they're saying how many milliliters. So I don't know how much of a solution I have. Of a 12% acid solution. So I'm going to write my percent in decimal form. 12% is 0.12. Should be mixed with, so now they're telling me about another solution. 500 milliliters of a 20% solution. So in decimal form, that's 0.20. To obtain, so now they're telling me about a third solution, a 17% solution. To find that amount, our milliliters of that 17% solution, I'm going to add solution 1 and solution 2 together. So if I look at this combined, when I multiply straight across, I'm going to have 0.12 times X. When I multiply 500 with that 0.2, they're both just numbers. So I end up with the number 100. And then for this solution 3, I need to be careful. I need to make sure I do that percent 0.17 times everything. So I need to put that X plus 500 in parentheses. For my equation, I'm going to add the first two solutions, so 0.12x plus 100, and it has to equal that third solution, the 0.17 times x plus 500. Now, I just solved this equation. I'm going to distribute to get rid of my parentheses, so I'll have 0.12x plus 100 equals 0.17x plus 85. Now I have x's on both sides of the equation. I'm going to subtract the 0.12x, the smaller one, from both sides to get my x's on one side of the equation. That gives me 100 equals 0.05x plus 85. I'm going to undo my addition with subtraction. That gives me 15 equals 0.05x. And I'm going to undo that multiplication with division. That gives me that 300 equals x. If I look back up at what x was, it was the milliliters of solution 1. So we need 300 milliliters of the 12% acid solution. If we look at the next example, it says find the concentration of the resulting solution when 500 milliliters of a 16% acid solution is mixed with 300 milliliters of a neutral solution. So I'm going to set up the same table where I have solution 1, solution 2, and solution 3. I'm going to have milliliters, percent, and the combined when I multiply them. If I look back at the problem, it says find the concentration of the resulting solution. So I don't know the percent of the solution I get when I mix them together. When 500 milliliters, so this is the solution that I'm mixing, of a 16% acid solution is mixed with 300 milliliters of a neutral solution. That neutral means there is no drug in it, so the percent is 0. Remember, to find the milliliters of my solution, I add the two solutions that I mixed together. So 500 plus 300 tells me there's 800 milliliters of our resulting solution. I'm going to multiply straight across. So 500 times 0.16 gives me 80. 300 times 0 gives me 0. And 800 times x gives me 800x. I'm going to set up my equation the same way. Solution 1 plus solution 2 equals solution 3. And this equation is much easier to solve. I add 80 and 0 to get that 80 equals 800x. I undo my multiplication with division, and I find that 0.1 equals x. Now remember, this is our percent in decimal form. So the last thing I have to do is turn that decimal into a percent. I can do that by bumping my decimal point 2 places to the right, or by multiplying by 100%. Either way, that tells me that we have a 10% acid solution. If I look at our last example, it says how many milliliters of water, a neutral solution, should be mixed with 500 milliliters of dextrose 10% water to obtain dextrose 5% water. I'm going to set up my table. We have solution 1, solution 2, and solution 3. I have milliliters, percent, and combined, which we get by multiplying. If I look up at this problem, how many milliliters of water should be mixed? So they're asking me about the first solution. So I don't know how many milliliters I need, and they tell me that water is a neutral solution again. Remember, that neutral means it has 0% drug in it, so I'll have 0 there. Should be mixed with 500 milliliters of dextrose 10% water, so that 10% is 0.1 or 0.10, to obtain dextrose 5% water. So they're telling me that I really have 0.05 for my resulting solution. To find the milliliters of that resulting solution, I need to add solution 1 and solution 2. When I multiply straight across, x times 0 is just 0. 500 times 0.1 is 50. And once again, I have a plus, so I need to make sure that I do that percent times that entire milliliter, so the x plus 500 in parentheses. To set up my equation, I do 0 plus 50, the solution 1, plus solution 2, equals solution 3. So my 0.05 times x plus 500. On my left-hand side, I know 0 plus 50 is just 50. On my right-hand side, I need to get rid of the parentheses. To get rid of parentheses, I distribute. So I'm going to have 0.05x plus 25. I undo addition with subtraction, so I'll subtract 25 from both sides. That gives me 25 equals 0.05x. I undo multiplication with division and find that 500 equals x. To make sure I'm giving the right units, I look back up. X was a milliliter, so we need 500 milliliters of that solution 1, so of water.